Right, so welcome everyone. I've now switched on recording, as you all will no doubt see on your devices. So welcome to our weekly call. In case anyone missed it, our focus today is going to be on the Split Horizon discovery proposal, which Tiru and Dan submitted to the IETF ADD working group certainly a few weeks ago. I'm not entirely sure. I can't remember the exact submission date. And I've, in conversations with a number of people over the last few weeks, the sort of the split horizon use case has come up on more than one occasion, including for ISPs that have sort of edge computing requirements. So I thought it would be useful to potentially air the Split Horizon proposal as it stands, which, as Tiru and Dan may confirm, I believe is currently mainly focused around enterprise users for obvious reasons, as that's the probably best known Split Horizon use case. But then we'll see in the discussion if there are sort of views on whether it could indeed be applicable in other environments, and whether there's interest in people contributing to the existing draft to help broaden its applicability. So first things first, let's welcome Tiru and Dan to the call. I think I saw you both on. Hi, Tiru. Yeah, sorry. Okay. Yeah. So what I propose to do is, if the two of you, I'll leave it to you how you want to play it. Want to kick off and sort of talk about the discovery proposal as it stands, and then we'll sort of see where the discussion takes us after that. And if you wish to present anything, you should be able to do so from either or both of your devices as appropriate.
Yeah, I'll do that, thanks, Andrew. So I'll present the slides. We just published a revised draft today morning, so I updated the slides based on the comments we received from the working group. So let me share the slides. And
Tiru, sorry to interrupt. It might just be me, but you sound very faint. Can anybody else hear Tiru okay, or is it just at my end?
It's garbled.
Yeah. I don't know if you've got any other microphone options, Tiru, at all.
Just a second.
It sounds to me more like a bandwidth limitation, Andrew.
Right.
Hello, can you hear me now?
That is significantly better, or at least it is to me. Hopefully others will concur.
Okay, great. Okay, let me share the slides, and I'll just give a brief intro on what happened and where we are at the current stage. So here we go. Can you see the slides?
Yep, that's on the screen now.
Okay. So just to give a brief background on this draft was the outcome of the discussions that happened in ADD working group. In the ADD interim that happened a couple of months back, we presented requirements of Split Horizon to the working group, and there was some interesting discussions that happened on these requirements, and we saw a definite interest in the working group on the Split Horizon DNS configuration, and that's the reason we published this draft. There's been a lot of discussion on the working group on two aspects of this draft. I will go over both of them. One of them is less contentious, that there seems to be good agreement on how the draft should progress. But for the other one, there was a lot of back and forth discussion, and there are some disagreements. I'll also go over that, and we'll see. like to take any questions and comments. So uh, just to go back and explain, the goals of this draft is basically to discover the local names, which are the private names. This is very similar to what you see in split DNS configuration in IETF, which is a standard that was published, I think, a couple of years back, where IETF provides the VPN client with the internal domain names, so that the client can use the internal DNS servers to resolve those domains. And if the VPN client configuration has a split DNS configuration, it can use a public resolver for resolving public domains. The other one is the one which is most debated at the working group, that if the network has a security policy that it wants to allow the endpoint to only use the network provided resolver, then we have is there a way for the client to identify that instead of the network just blocking the traffic to these public resolvers? Uh, the scope of the draft has been we have the working group has already adapted two drafts. One is the DHCP-RA based, and the other one is the DNS based discovery mechanisms, and they work in any type of network. But this scope of this draft is pretty much restricted to networks where the client authenticate to the network, especially using unique credentials, unlike the way user authenticates to a home network with shared credentials. So this is specifically drafted for identifying your enterprise networks where the client has unique credentials provided by your IT admin, and he changes that after he joins the network, and has to frequently keep updating his credentials to log into the network. And this is explicitly written, developed for those networks, so that the client has an explicit trust with these networks. For example, it could be my enterprise network that I work for, and I bring in my own mobile device or my smartwatch into the enterprise network, and I want to use that device to access the enterprise resources. So these are type of devices which are typically, if you see in the enterprise realm, they are unmanaged BOID devices. These devices don't have any MDM or any configuration profile. Configuration profile is typically the Wi-Fi client certificate and other configuration parameters that could be installed on your mobile device that both Apple and Android support today. So these BOD devices are very vanilla, that you don't have any configuration on these endpoints other than the user inputting the credentials to log into the network, which is typically based on e-password or e-appreciate key, PSK based authentication techniques that are typically used. And for these devices, how do we provide the local domain names, and how does the network tell that it's blocking access to the public resolvers, and the client has to figure out whether it still wants to access the network, or it wants to change its setting only for this specific network. Uh, so what we have done to solve this problem is pretty straightforward, in the sense that we picked what provisioning domain we are leveraging. Provisioning domains is already a standard that's there, that's been there for quite a while at IETF, and it's basically used for providing network configuration information to endpoints. It's very useful, especially you have multiple interfaces, your router has multiple upstream links, it's connected to multiple ISPs. How do you know the provisioning information of each of those upstream ISPs? So what we are trying to do with provisioning domains is, provisioning domains allows to provide a lot of information as part of web PVDs, which is as part of DHCP, you discover the web PVD, which is an HTTPS server, and you talk to the HTTPS server and you get a lot of information about the network configuration, which the client can use to make decisions whether the network is allowing split DNS configuration, what are the domains that are hosted by the enterprise network that the client wants to use, and various other information. So we're just leveraging that existing PVD concept, and we're enhancing the existing PVD key to provide domains which could be either private only. That means that those domains are not visible outside the enterprise network, and they could be public, but have a different version just because you're logged within the enterprise networks, and it's only visible to the employees or users or guest users who have authenticated to the network, and only they can see the private version of the public domain that is there. That's a private content that you could see because you logged into the network. We also have a PVD key. It's basically nothing but a policy expression it's not mandating anything with regard to what the client should do or shouldn't do. It's just conveying back to the client saying that, hey, this network is going to try and block all DNS queries to external resolvers that are not provided by the network, and the client is free to decide whatever it wants to do with regard to this policy. It can try to probe and see if it's indeed getting blocked. It can decide to use a different network. It can decide to change the setting so that if the client or user trusts this network, it can override the setting to use this network's a network provided resolver. It also has the PVD key for conveying the human friendly description of the reason for blocking that, because an end user needs to know what is the reason why the network is blocking it, and that may be an useful piece of information for an user to know why the access to public resolvers are blocked. So this is typically in cases where an user has explicitly gone and pre-configured his operating system, his or her operating system, to use a pre-configured public resolver. And in most of the cases, this is not be as this scenario where endpoints do use the discovery mechanisms that are being discussed in ad working group, and they use the network provided resolver. So this is really helpful for cases where there could be apps, there could be operating systems or browser which just pick the pre-configured one without understanding what the network is trying to do, and what would they do if the network starts blocking access to these resolvers. uh, so web PVD, there's RFC 8801 defines several of these parameters. I'm not going to go over them, but split DNS allowed is just a simple Boolean attribute which just says whether a split DNS configuration is allowed or blocked, and the DNS zones lists both the private and public domains that the enterprise is hosting. And that's really helpful for endpoints to decide how to resolve these domains. One of the ones that we discussed a lot in the working group and made good progress in the last couple of revisions is any network. For example, in this case, in the previous slide, if you see, any network could lie back to the client and say that, hey, I own all the domains in right. I own Gmail, I own YouTube. And what does the client do? How does the client know if the network is lying to it? It wants to invade the privacy by giving domains which are indeed public, which may not be something that the enterprise network hosts, but it is trying to lie to the user. How does the endpoint client detect that, right? So for that, we have discussed that at the working group, and a very simple technique has been proposed after several discussions back and forth. That what the client does is it just has to do an NS query, which is to look up the name server associated with the domains. So that would have to be done with either a pre-configured resolver to have a secured leg where no man in the middle device could tamper it, or it has to use a local resolver where the response is validated. Then the name server's response that comes has to be exactly matching the domain name that gets discovered, either using DNR or DDR drafts. And then, or it could be a subdomain of that, in case if imagine a branch office hosting a DOS-DOT forwarder and has a split configuration with direct internet access, then the subdomain would match the IDN. So that authoritatively proves to the client that, hey, these domains are actually indeed owned by my enterprise network, and I can all that it has to do is then establish a secure communication to the network designated resolver, either use DOH-DOT, and resolve those domains. And in case if the match is not successful, it pretty much is evident back to the client that the network is lying and wants to probably invade the privacy of the user, and then can take appropriate action, like probably recommending the user to not use this network because it's doing something fishy. And yeah, I mean, we have just published a revised version of this draft to address several of the comments that we received from the working group. And the most discussed one is the split allowed DNS, where uh, there's a certain group which thinks that we should not be discussing any internal policy that should be communicated back to the client. But I think we'll see how the working group progresses. But uh, I think rest all comments have been addressed, and I would like to hear from others how they plan to use this in other networks, and what their other use cases are. Uh, any questions?
Thanks, Tiru. And I know there was some discussion early on when, well, I think when you first published this, as to whether split horizon was even a requirement, which frankly surprised me because I thought that was well understood. It was definitely a requirement in the enterprise space. But let's see if people have so either questions or comments or thoughts on wider applicability beyond the enterprise environment. I see Barbara has raised her hand first, so please, anyone else use Zoom to raise your hand, or if for whatever reason you can't raise your hand or can't sort of in an environment where you can't talk, then pop something in the chat and I'll read it out on your behalf. But Barbara, over to you.
So I'm curious, since this seems to be targeted at the enterprise and the BYOD devices, if an enterprise has a policy that certain internet sites are not allowed to be accessed, shouldn't the enterprise claim to own those so that it can then block access to them? Or do you think devices should see that as a privacy violation and that they should have the right to view whatever pornographic sites they want to over the enterprise network?
Yeah, I mean, that's a good question. So as you know, these sites keep changing, right? I mean, every day a new site crops up, which could be either a malicious site or a botnet site. I mean, DJ is a typical algorithm that's used by malware to host new sites. So they're not static piece of information that could be, I mean, those domains, if you see, for example, McAfee has its own threat intelligence of domains which are malicious, and it runs in like millions of domains that are there. So it's not quite easy to publish those domains as is. But if you see, there's several work happening in DNSOP and other working groups where if the enterprise network decides to block a domain, then an error code would be written, extended EDNS error option is written to the client, which says at a very high level what would be the reason why the access was blocked. It's for the client to know why the domain is blocked. And we are trying to enhance that by providing an HTTPS URL back to the client saying that this was the reason why this domain was blocked, what was the, who is blocking it, who's the contact person or the email or phone number of the person who is blocking that, so the user actually knows why these specific domains are blocked. Because if you see, the number of categories and the number of reasons because of which an enterprise could block a domain is quite varying. For example, our McAfee threat intelligence has around close to 128 categories of domains because of which an enterprise could have a policy of blocking access to these domains. Some of the others that I have seen have around 60 categories. Some may have more categories. So the categories are not a standard mechanism that, and the category that one a security vendor picks may be different from the other security vendor. So we can standardize those categories. But those error codes that will be returned by the DNS server, which is performing the filtering, will be quite useful for the client to know the reason why it is blocked.
Yeah, but to block it, don't you have to claim ownership of it, or can you block it without making sure that the queries for that domain goes through your DNS? I mean, because you said it's a privacy violation, and you know, and I'm curious, you know, why is it a privacy violation for a BYOD device not to be allowed to use an enterprise network any way they want, or for the enterprise to say we own all domains?
I'm not sure I get the question. So there's no privacy violation here today. Enterprises do that already, and even with DOH, DOT, they can still continue to do that. For example, if you see, if they discovers any network designated resolver, it would still connect to that, and the enterprise can still continue to block access to certain domains. So there's no privacy violation there. It's because you pick that resolver, the resolver can block you access to certain domains. And that's happening today and will happen even with encrypted DNS. So I don't get the challenge. I don't see any challenge there.
Is the question around redirection? In other words, using DNS to redirect to a man-in-the-middle proxy. Is that what the question is relating to?
I guess maybe I just misunderstood the presentation. I thought there was some discussion about you know, I guess the enterprise would claim, you know, that some things would go to one DNS server and others would go elsewhere. And, you know, if, well, anyway, okay.
Go back to the web PVD example.
Yeah.
You said that there was a concern of how to validate the names that are in DNS zones to see if
Right.
the other DNS is actually allowed to capture them, and if it was discovered that it shouldn't be, there would be a privacy violation. So I think Barbara's question is, if we wanted to block a porn site, wouldn't we want to add its name to DNS zones so that we could do that?
No, you don't have to do that. So if you want to block a specific adult site, then all that you have to do is say that split DNS allowed is equal to false, which means to say that you would want to filter all the DNS traffic that is going from the endpoints, and the DNS zones just has to list your private and your public resolvers, public domains that you have. And the flag that is of real importance for you, because you're doing filtering and you want to mandate the clients not to access, let's say, porn sites. In that case, the flag has to be set to false. This is only for mostly relevant for cases where the client has a configuration where it wants to, and the enterprise network wants to allow you to use a public resolver for public domains, but wants to use the network provided resolver for the internal domains.
Right. So I've got one DNS for my VPN, and I've got another DNS for the internet, and I want to filter the internet DNS. So I kind of want both. I want everything. I'm a standard American.
Thank you. I thought it
Don't
was
I
just
want
me.
split DNS allowed true?
Sorry, I didn't get that question. Could you just repeat that? Sorry, there was some breakage.
Well, I've got a situation where I've got a VPN, so I have a VPN DNS server. So I really want split DNS allowed,
Okay.
but I also want to filter the public DNS server.
Sure. And that's quite possible because there are two different interfaces. Once you have a VPN client there, the VPN configuration that you have for that, the clients typically have configurations, whether it's going to pick split DNS or it's going to tunnel all the traffic back to the VPN server, in which case you could have a policy saying all the DNS traffic should go back to my VPN server, and I would pick the resolver that is provided by my VPN provider. So that takes care of the VPN case where whatever traffic is going through the tunnel picks the VPN provider's resolver. But for any traffic which is not going through the VPN, that will be still enforced by your network policy, which is what split DNS allowed will tell you that, hey, whether it's going to allow or block DNS traffic using any other resolver.
Does that clarify the question, Barbara and Roy?
I think the confusion may be on the terminology, right? Because in VPN parlance, you use split DNS to segregate VPN DNS from non-VPN DNS.
Right.
And what you're saying is slightly different than that. So what happens to the example that was given, if you're tunneling just the corporate DNS traffic and as such, the corporate IP, the internal IPs for those addresses, but everything else is going direct to the internet, and you want for that traffic going direct to the internet to apply security policies, maybe like a cloud DNS security service. How do you express that in this policy?
So there are two parts to this, right? Let's say you have a split VPN configuration and I connect to my home network, right? And in case all my enterprise traffic is going through the VPN and all my internet traffic is bypassed from my VPN. So in that case, the endpoint would have the configuration of this PVD. It would see whether what are all the what are the network provided resolvers, and it would start using them by default, right? And if you have another resolver configured and you don't want to use my network provided resolver, this flag will actually tell back to the client that, hey, is it even allowed to use a public resolver when it is attached to this network? And if it is not, the network is going to start trying to block that, and the client has to eventually fall back and pick what the network is giving, or has to switch to some other network. But the whole idea is the discovery process ensures that the endpoint does discover what the network is giving in, and the network can still enforce the policies.
I think my issue is that I'm not particularly familiar with these PVD router advertisements. So I'm trying to intuit the meaning of DNS zones from context, and I'm not succeeding. My interpretation when you gave the presentation was that that was declaring the list of FQDN zones that would be available from the local VPN DNS.
No, this is not for a VPN use case. This is for a use case where a device attached to a network, and the network provides the PVD as part of the network configuration information. This has nothing to do with VPNs.
So
it could be used by VPNs, but it's as simple as I join my enterprise network using my device, and this is the network configuration I learn.
But what is the effect of listing city.other.test and example.com? What does that tell it to do?
So it tells that if the endpoint has, for example, a pre-configured resolver, and it wants to use that for resolving all domains, if it hadn't got this information, it would not know how to resolve this, because, for example, if city.other.test is a private domain and the client is configured to use a public resolver like Cloudflare or Google's, then it can't resolve city.other.com. It's telling the client that these are the private domains, and it has to use the local resolver for resolving those domains.
Right. And I think that's what I just said, right?
Yeah.
We have piratebay.com that is on the public internet server, and we want to stop the guy from accessing that. So we're going to move it over to our local DNS from the public DNS. So we list Pirate Bay in DNS zones. That tells it not to go to the internet to look it up.
That's not the intent of this draft at all. It's only for listing the domains that the enterprise hosts, so that the client can resolve them successfully.
As I think I understand it, the intent of this is, if you've got an enterprise with some local names that it only wants to route within its local network, it would list those under DNS zones. So basically it's saying you won't find these on the internet, I own them and they're all here. So it's purely for routing locally, as opposed to, I think, what Barbara and Roy, if I've understood what you're driving at, you're looking for a way of filtering content, and that's not, I don't think, the point of the DNS zones list. It's purely for a local routing list as opposed to a filtering list. So you'd have to have
if you
filtering.
If you wanted to filter something publicly, how does this discover a DOS server that does filtering and not just Cloudflare?
This draft is not discussing any discovery mechanism. Discovery mechanisms are already covered in ADD working group using two drafts, which is TDR and DNR. TDR is based on DHCP-RA extension, and TDR is based on an DNS-based discovery mechanism. Those are the ones which will help the endpoint discover the network provider diverged DoT servers.
So this would need to be combined with another mechanism to discover.
Yeah,
filtering.
I mean, it's not replacing them or doing anything. They are mandatory ones if you have to use your discover and use your network provided resolvers.
Okay.
So this is not complement. This is only complementing the work already happening in ADD, and it is not replacing or competing with any of the ADD working group drafts. So hopefully that clarifies.
Thanks.
Okay, thanks, Barbara and Roy and Vinny. I know John had his hand raised and Jim did. May not have it raised now. I'll check in a minute. But John, do you want to jump in now?
Sure. Hi. I had a question on the PVD key that talks about the description for the block. I think that's possibly part of the confusion here, and that there is a reference to a block. And the question is, how does this complement or replace any kind of information that may be eventually included in the extended error messages? And there is some text that I suspect will be part of extended error messages in the future.
Yeah, so that's a good question. So this is basically a text before. This is supposed to give you a human-friendly description even before you access a specific domain or access a public resolver. Today, if you see the standard that is already there, it just gives an error code. It does not give any human-friendly description. So that's one spec that we are pushing at DNSOP working group for adoption, for providing human-friendly descriptions back to the user. But the current spec, which is recently standardized by DNSOP, doesn't give back any human-friendly description. All that it gives is standard error codes.
No, I understand that, but the human-friendly description would have to be tailored to match the same error code. In other words, there is a mapping between the human-friendly text and the error code number. So I guess I'm not understanding how this block description and in any way fits into split DNS as a concept. Isn't that really supposed to be handled by extended DNS error?
It's supposed to be handled by extended DNS error, but the problem is it's not giving today any human-friendly description. So that's the reason it was added just as an field to help the user to realize why access to the pre-configured resolvers are getting blocked, rather than just relying on a. Yeah.
So are you saying that this is talking about why access to external resolvers is being blocked, or why individual blocks are occurring against?
No, this is only talking about why access to a public resolver is being blocked.
Access to a public resolver. Okay. And then how is the determination, or is there any description made in your draft about how the determination of how a public or an external resolver is determined? Meaning, how do you discover and or block access to other DNS resolvers, or is that left as a...
Yeah, it's outside the scope of the draft today.
Okay.
Many resolvers integrated with threat intelligence databases like OpenDNS or McAfee, right? They have identified of these public resolvers and are classifying them as proxy resolvers and blocking them. It's up to the admin, IT admin to configure. It's not blocked by default. The IT admin always has the luxury to decide whether he wants to block these resolvers, and the category for them is a proxy, anonymizer or a proxy, and that's the reason the enterprise admin can decide to block access to them.
Okay, so in your web PVD example, if you can go down to that slide for just a moment, sure. Is there an indication that says, so split DNS allowed, if that is set to false, then any access to, by some definition, any access to other resolvers other than the one provided by the RFC 8801 provided resolver, would create this message that would be presented to the user. Is that correct? So this is really, it's a protocol level message, not a specific lookup message, right?
That's right.
Okay, thank you.
Right. Thanks for the clarification. Jim?
Thanks, sir. Bunch of points here. Just run through the actual back in reverse chronological order. Just to what John was talking about a moment ago, it's quite common in enterprise networks that DNS queries are blocked from leaving the enterprise networks except for the trusted resolvers operated by the enterprise itself. So edge devices and other things are not allowed to talk to the outside world, at least as far as DNS is concerned. You've got to go through the resolver that the company provides, because that's just how it's done. End of story. The point I was going to make about Tiru's thing about human understandable, human friendly error messages is that I don't think this belongs in the draft at all. That's something to be done in the application software, not in the protocol. And the reason for that is that these DNS lookups inside enterprise networks are not necessarily just coming from bring your own devices. I'm thinking particular things like mail servers and stuff of that nature. They're not going to be able to make sense of a user-friendly error message if they get it, other than to report that in the logs. So I think it may be better to try and concentrate just on what's going to be affected by the extended error codes being returned from the DNS lookups, and leave it up to the end application to decide whether or not to translate that into a user-friendly error message. And also, a user-friendly error message in English is not going to be much help to someone that only understands Chinese, or vice versa. And so I worry about talking about human-friendly error messages as a general concept. I don't think we should be trying to build these into protocols. And the final point I want to make goes back to what Barbara mentioned before about privacy concerns. That might be just an overstatement of the possible issues here about using split DNS and people looking up naughty domain names. There can be other issues as well, like human resources concerns and stuff of that nature. I remember that from the time when I was doing enterprise DNS, which admittedly was a long time ago. So the sort of things that could be a concern would be an employee accessing a gambling site during office hours. So at that point, then you may want to get involved with the issue of a duty of care for the employee. You know, we think you've got a problem here, an addiction or a compulsive behaviour, and as an employer, we've got a duty of care to look after you. So those can be not necessarily privacy issues, but they're part of a bigger concern. And maybe it's better to talk about the context of split DNS setups is to talk about it in terms of policy violations or employer policy violations rather than purely the privacy considerations. Just a thought.
Good comments there. So I'll just clarify on the human-friendly description. So this entire human-friendly description is coming over a web PVD, which is HTTPS. So the language could be negotiated as part of the HTTP request response, and the response, the human-friendly description need not come in English. It could come in Chinese or any other language that the user would understand. That's one advantage of using web PVDs.
Yes,
if you go back and look.
Tiru,
If you go back and
not all of those messages are going to be getting presented to humans.
Yeah,
should make the assumption they're going to humans.
Yeah, so it's just an optional string that would give some additional information, whether it's finally the application who is receiving this information has to make a call whether it's going to use that just for logging or going to provide that information back to the user. And there was some discussion that providing back this information to the user would be helpful for him or her to decide why the network is blocking access to these domains, public resolvers especially, because if you see the DNS error response codes that we have, it's just 15, 16, 17, which says the enterprise decided to filter this for internal security policies, and there's not much of information on why, a more granular information that is available, or on why the access to these public resolvers are blocked, and that look like an easy piece of information that could be provided back to the user. And today, if we had any other mechanism of giving that, we would not have to list this additional PVD, but we saw that was the only option. And I agree, this only works for your IoT devices which have an user interface, and doesn't work for IoT devices which are headless basically. So, but it helps in cases where you typically bring in your laptops or mobile devices, and the human-friendly description helps. And if it doesn't help, we can just ignore that. So it's just it's nothing about any policy enforcement or anything. It's just to help the user to decide why the network is blocking it, and whether it wants to still use that network or abandon using that network.
Yep. Okay, thanks, Jim. See, there's a query in the chat Tiru and Dan, which is from Gianpaolo. Is there a way this approach could be extended to the home router for non-enterprise use cases? For the home router case where the DNS resolver is in the router and there are local services and or domains?
Yeah, that's a very good question. And I mean, in fact, if you see it goes back to the requirements that was presented in the interim. And one of the major issues was to restrict this draft to explicitly trusted networks like enterprises. The whole problem why it didn't go into enterprise networks was especially because of the shared credentials, and you could be even attaching to an evil twin. And probably the event will can claim that, hey, split DNS is not allowed when the home network is actually allowing split DNS. So how do you trust the configuration that is coming from networks where you really don't know, because you're not authenticating those networks, because all that you're doing is shared credentials. This mechanism can be used in any network, but it was restricted to explicitly trusted networks where the user explicitly turns on this option. Because of those problems that we see, that you walk into a coffee shop or a hotel or a home network, you really don't know whether you're joining your home or somebody else's home network or an evil twin, and bypass all your security settings that you have on the device if you pick what the PPD says. So that was the main reason to restrict the scope of this draft. For example, it would work in mobile networks because mobile networks have very strong eSIM-based authentication, and there's no way that you could get another mobile network acting as an evil twin. So it works in any network where you have a strong authentication of the network, and it should work in those cases.
Yeah, okay, that's a good point. Now, I know we've got a number of people from ISPs on the call. I don't know if anyone wants to either sort of continue the point that Gianpaolo raised and maybe extend the discussion around the home router case, or indeed to the point Tiru just brought up around the sort of mobile network, because I know from discussions there were a few thoughts about how this might be applicable to edge computing requirements, particularly on mobile networks. So I don't know if anyone wants to come in just to expand on that a little. Glenn?
Yeah, hey there. So my one comment on that would be, the IETF can say what gets restricted to what. When people take it and adopt it and deploy it, the IETF really, it doesn't have any enforcement capabilities. So it's entirely possible somebody will take, this once we get it figured out and actually build in their product or deploy in different environments. That's going to happen, right? I mean, it's just reality of how things get adopted. We build them around particular use cases, but how they get deployed is out of our hands.
Yeah, fair comment.
Yeah, I agree.
User innovation. Although I guess, given what you described, Tiru, there would need to be ownership of the domain, so that would still need to be addressed.
Yeah, for example, we provide VPN providers like Tunnelware, which McAfee had acquired around 3 years back. And what we do in a Tunnelware configuration is we explicitly ask the user to enable that, disable that in specific networks. So it's turned on in all the networks by default. So if I'm walking to my enterprise network, I have a specific option saying that, hey, I'm walking to my enterprise network, I don't want my VPN to be turned on, because the user knows what networks to trust. So this is very similar concept to that. It's up to the user to decide whether it wants to turn this option or not, and we wanted to really keep it restrictive. But yeah, hey, whether operating systems and applications want to keep it, keep this in all the networks irrespective of the trust levels, they can continue to do that. But yeah, the standard does not cannot restrict that. It's up to the implementations. But PVD is a generic concept that could be used in any network.
Yeah, fair point. Gianpaolo, I don't know if you want to come back on that since you raised the question on the chat, or indeed if you're able to. You might not be in a position where you can talk at the moment. I'll just pause for a moment in case you want to unmute or pop in a follow-up question in the chat if that's easier. I'm guessing possibly not, unless it's a very long question that or follow-up comment that you're typing. So let's see whilst we just wait for that. Does anyone else have any questions for Tiru and Dan on this, or indeed any thoughts on? Yeah, Jason, come on.
It's the DNS.
You're breaking up a bit there, Jason. Do you want to try again?
I can do it after my Chris call at 12:30.
I think Jason is talking to someone else entirely.
Okay.
That's
why I couldn't quite hear what he was saying. Fair enough. Thank you, John, for the clarification. So anyone else got any questions or comments on this, just while we have a moment?
I'll throw one out there. So, my comment earlier that people will adopt, and people will use how they will. One area that I do worry about potentially is somebody trying to build a security solution around this for really low-end IoT devices that really don't have a lot of smarts on board, and trying to sort of build an IoT management framework built upon this concept of splitting DNSs and trying to filter out successfully things that they don't want their IT environment on their home networks and edge networks to talk to. I don't know how we deal with that. I just raised it because I do know that there's people out there that are scratching their heads in IoT and trying to figure out the path forward. And when we get into some of this space, I can see some people going, yeah, I can see how to adapt this to wrap some control around what my IoT devices are doing on the home networks. And I don't know if we ultimately need to provide some kind of guidance to say this is a very bad idea, or if we need to sort of figure out how to wrap it and say it's a very bad idea unless you do it this way. One of those two. I don't think we're ever going to come up with guidance to say it's a very good idea and go ahead and use it, because it just does not seem like a good idea. I don't know if Tiru wants to chime in on that.
Yeah, I mean, IoT devices are a tricky aspect, and I mean, it's a broken one, especially in home segment because of the off-the-shelf devices that you purchase, and they have their own onboarding mechanisms, which is quite different. But the one that at least I'm closely following is the work happening in device provisioning protocol, which is a standard mechanism for provisioning devices, and all this configuration can be securely pushed to an IoT device if it supports TPP kind of a protocol. IETF is working on several protocols at IETF called Brisky and Secure Zero Trust Provisioning. Those I see probably will get adapted by enterprise IoT devices, but even the concepts like MUD, I can tell you that I haven't seen any single consumer IoT device adapting that other than the enterprise devices. So I see two types of IoT devices just picking up what the network gives and just uses that, or I've seen some specific IoT devices like Fire TV Stick and others picking a pre-configured resolver and using that, and if the network blocks it, probably it has to fall back and pick what the network is giving. And I don't think there's a case where these home IoT devices are going to pick a complex configuration of split DNS where it wants to use a public resolver for certain domains and use some other resolver that the network is giving. So I haven't encountered that kind of a complex configuration on the IoT devices that are there in the home. But yeah, unfortunately, that entire segment is so fractured that whatever we do at IETF or any of the DPP forms, IoT devices can continue to do their own proprietary way of onboarding and bootstrapping the configuration, and we may not have no control over this, especially the consumer grade IoT devices.
Yeah, I think you're right, Tiru, that the enterprise space is more hopeful. The home space is just going to be terrible forever. Because people want cheap, and cheap doesn't equate with implementing the latest IETF mandated approaches to doing things.
Yep.
Unfortunately, I'm going to be a cynic.
Yep. And the best part is, I mean, I can tell you that we were trying to get 802.NX into home network so that we have unique credentials. And I've not seen a single IoT device which says I will support EAP or any of the techniques. They're still struck with WPA3 and WPA2 techniques, which have several vulnerabilities. So, I mean, yeah, it's going to take several years for them to catch up. Yeah.
We can probably all agree that IoT is a bit of a mess.
Yeah, and there's some work happening. At least I saw Michael Richardson recently publishing a draft which got adapted by the OPS AWG working group, which talks about the DNS considerations for IoT devices with regard to MUD and other policies that the enterprise networks want to enforce. So, but that I believe is quite specific to enterprise. But I think it's a good start to look into it if someone is interested into what are the challenges with regard to IoT devices and DNS filtering for IoT devices.
Great. Okay, I'm conscious of the time, so we've nearly used our allotted hour. So just one final question then for the two of you. If sort of based on this discussion, it sort of sparks some thoughts and somebody wants to maybe come back to you with some either input for the draft as it stands or ideas on how it could be expanded, is it if they do that via the list, I'm guessing that's probably the best approach.
Yes, I would recommend not to do that in this communication form. Better to do it in the ad working group so that we have all the discussions there.
Yeah, indeed. So anyone with any thoughts on that via the ADD list, if you can, please, that'd be much appreciated. And with that, I think let's wrap up there. So thanks, Tiru and Dan, for sort of taking the time today to share this with us. I think you've given some food for thought. If you want to, if you're able to email me the slides, I'll send those out with a link to the recording shortly.
Sure.
So yeah. Thank you both for doing that. We've just maybe got a minute or two if anyone has anything else they want to raise before we finish the call now. So just take a moment if anyone does have anything else they wish to bring up in the remaining 3 minutes, 2 minutes. Or if not, thanks everyone for joining. It's Easter Monday next Monday, so as I mentioned at the start, we won't have a call this time next week. So have a great week, everyone, and we'll see you all again in 2 weeks' time. So thanks everyone for your time. Have a marvelous week.
Bye, guys.
Thank you. Bye-bye.
Bye all.
Bye all.